Welcome to the lecture 2 of blockchain series. Today we will discuss about principles and technology of the blockchain. In the previous lecture we covered the overview of the blockchain, and today we are going to cover blockchain and the principles of technology. The topics we are going to cover today are the principles of the blockchain, blockchain process, blockchain components, blockchain structure, block hash generation process, and the version of the blockchain. So, let us talk about the principles of the blockchain. The first and the foremost principle of the blockchain is distributed. All the participants has its own copy of the ledger. That is the basic principles of the blockchain. Decentralized. There is no central governing or a third party involved. It is a group of nodes maintaining the network. Immutable. All the transactions recorded on blockchain network cannot be altered or reversed in general circumstances. Time stamped and sequence. All the transactions have to be time stamped, and they should be in the sequence They are recorded. All the transactions are recorded in the chronological order. Consensus. Each and every transaction has to be verified and approved by all the participants of the blockchain network, and we call it as the consensus process. Security. No single central point of failure. No single person can damage the entire network of security. That is the one of the basic fundamentals of the principles of the blockchain. Privacy. The identity of the participants, especially in the public blockchain, are not compromised. It is established as a separate entity for its user to protect privacy, both online and offline. Inclusive. Everyone is independent to participate without any discrimination. Anyone and everyone who has the internet connection should be able to participate in the public blockchains. Cryptography. All transactions are individually secured and digitally signed by owners. Each block has to be secured as a hash value. Now, let us understand the blockchain process. See this as number of steps involved. The first step is initiate transaction. So, any person who initiate the transaction, this is the first step. Second step, which we call as a broadcast. Transaction is put in a block and then broadcasted into peer-to-peer network. We call it as a nodes in the network. So, once the transaction has been done, it has been put in a block and broadcasted to the network, so that people can start verifying and putting it in a block. Second is proof of work. Here the miners comes. Here the network of the people, other people, they race towards and figure it out and verify and secure the block, and we call it as the proof of work. And once whosoever is the first person who says this has been done based on certain algorithm, we will discuss it more on the hashing process, that miner will be rewarded for verification of the block transaction. And once that has been recorded, that verified block is being added back to the blockchain, the bigger chain. Now, you have a new baby or a new block in a blockchain, still not completed. Now, this is the time when all the participants verify with their own ledgers and figure it out, is this transaction really a validated transaction? If everyone agrees to it, this is a valid, this is a consensus process, that is where your transaction ends, because once you verified it, then that block will be shared across other nodes, so that they can also update that ledger. So, your block, this is how the journey goes when the transaction comes in. So, again say you have a transaction, which comes to the network. We put it in a block, broadcast it to the people to verify. Number of miners come to the race condition. Whosoever first verify and secures the block gets rewarded. Once the block has been verified and secured, it put it in a blockchain, and once it has been blockchain added into blockchain, then it has to be verified as part of the consensus process by the other members of the network, and once that is verified, that updated ledger will be shared across the network. Now, to understand this, we talked about miners and nodes in the previous slide. What exactly it is? So, what are the blockchain components? So, the first is block. Consider the block as in a page in a ledger. So, basically you have a lot of in a page of ledger you have a lot of transactions written out. Ravi has sent a money to Saurabh, Saurabh has sent a money to bank, all those kind of things happens, am I right? So, it contains transaction information. Each block has two parts. One is the header part and second is the long list of transactions part. Each block has its own unique nonce and a hash. We will talk about nonce. So, consider nonce as a magical number. So, each block has its own nonce number and a hash. Now, hash number is a cryptic number for each block, and that hash number cannot be duplicated. That is always a unique. We call it the digital footprint of the block. Fingerprint, digital fingerprint. Ledger. Ledger is a list of blocks, correct, of all the transactions. Distributed ledgers. So, the ledger which has been distributed across has via nodes connected to a chain. It is also called the digital ledger. So, ledger which you maintain on the digital is called the digital ledger. The participants who has the required permission or appropriate. So, basically Rahul and Ravi can see the transactions which they have or they participated, am I right, which they have permission for. Nodes. Nodes is nothing but a computer system which has its own copy of ledger. Nodes. So, whenever there is a transaction happens, a block is added, the nodes get updated. The ledger and the nodes get updated. Okay. So, nodes also does the transaction processing and block creation. So, in the previous slide we have seen the block has been created and then broadcasted, that is done by one of the nodes. So, nodes can do all these also. And again then we have network, where we say peer-to-peer network of nodes with a required software. So, anyone which has a required software for the blockchain. So, because when I say required software, there are multiple softwares available for blockchain. So, whenever any computer which is connected over the internet with a required network required software install is part of a network. And the last is the miners. So, consider miners as accountants who verify and records. If you see in the previous slide of the blockchain process, we said we have to verify the transactions, am I right? So, the same nodes start thinking as a miners. Now, how they do it? Miners run a special kind of algorithm on their softwares, which verifies and secures the block, and that secured block has to be verified by other block nodes before adding into the blockchain ledger. Then the miners can create a new block on the chain through the process called mining. That is how we do it. We will talk about mining and everything in later chapters. Consider this. Now, understand the blockchain. So, blockchain is the ordered list of blocks. You can see you have 3 blocks here, correct? So, it is an ordered list. Every block refers to the previous block of transactions. Consider this as a linked list data structure, where each linked list node is referring to the previous nodes. So, basically you are having a pointer to the previous nodes. So, block n is referring to the block 2 is referring to the block 1, and there is a special reason why I put as a block, because this in some cases this is called as a genesis block. Now, first block in the chain does not have any previous reference, because this is the starting. So, there is no reference to the previous block. There are two more things we have to understand here. First is the term called block height. When I say block height, it represents the number of blocks that comes before that block in the blockchain. For example, the block height of block 1 is 0 and a block height of the block 2 is 1. Now, what is the blockchain height? Now, blockchain height represents the height of the highest block. So, let us say if the height of the block n is 10,000, in that case the blockchain height will be 10,000, because this block n is the highest block height. The second structure we talk about is a block. So, as I said, block has two parts. One is the header. So, we are saying this is header. Another we are saying is the body of block. Now, header also has lot of information. So, first information is the previous block hash. Previous hash block is the value of the previous block, which is also called as a parent block. So, think it as a pointer to the previous block node in the linked list. Block hash. The block hash is the block value generated using SHA-256 cryptographic algorithm. Even the previous hash block follows the same thing, because when that block has been generated, it is generated through this process only. It identifies this block uniquely, for which this block hash belongs to, and as I said, we call it as a digital fingerprint. Other informations are version. There is a version field in the header which is to track the software and the protocol upgrades. So, we can figure it out, this block belongs to which version and which protocol it is running underlying this block. Timestamp, when this block has been created. Then the nonce. Then this nonce, this is a magical field, am I right? So, whenever you generate any block hash, there is always a rule to what kind of a hash number it should be generated. These are called validation rules defined by blockchain governance. So, to get that number, you need a number which can be used. So, this number can be used or can be changed by miner to get that 532-bit number of field value. Okay. And one condition is that the block will always has less than or equal to the current target of the network stage. So, there is a stage called difficult stage and a Markov root that has to be taken care of this here. Now, the last is the body of the block. Now, when in the body of the block, it is only the transaction entries comes in. There is nothing like any metadata. So, header belongs to the metadata, body of the blocks belongs to the transactional data. Now, the hash block comprises of both. So, all the things, when you put this, all the values of this except the block hash value, we take it and we use a such algorithm, cryptographic algorithm, to generate a block hash values. Now, let us understand the block hash generation process. We take previous block hash value, transaction details, nonce number and other values, am I right? And we give that value to the hash algorithm to generate 256 bit or 64 character length of unique block hash values for the particular hash. So, let us consider we have a block here. We have a block which is the timestamp this, block hash this, and we have a number which is generating from the 4, and then we have a body called transaction 1 and transaction 2, which is these are the transactions, and this is a block hash value, and this is a magical number. And here is the timestamp. So, this shows when and which block has been created. Now, let us create, I am creating a new block. Now, in new block, I need to fill in first the previous hash block. To see this number, is same as this number. So, this shows this is how it is integrated with the previous block. This talks about when this has been generated. Now, see, this number and this number are different, because I said nonce is a magical number which minus gives to generate a unique block hash value, and this block has just one transaction. Now, the process of generating a block hash is something like this. So, we take previous values and generate this, send it to the algorithm. Now, an algorithm generates the hash value. Then this hash value matches with the signature condition. So, there is a condition allowed. For example, the condition has been said that all the block hash values should have leading zeros. So, it checks that the generated hash value has the leading zeros or not. If not, then the miner goes back and changes the nonce value here. And the moment he changes the value, and then this entire process runs again. And if again we do not see the signature hash value which is coming up with the 4 zeros, leading with the 4 zeros, then again this process goes back. And the miners keep on doing it till the time they get a hash value based on the signature condition. So, in our case, we said with the 4 with the leading process, and the process of repeatedly changing the nonce and hashing the block data to get the right block hash, which is a verifiable against signature, is called mining. Now, let us say you got the required block hash value. Then what happens is you add this hash value here, and that is how your block is complete. So, to understand this more interestingly, your hash value depends on the values of previous hash, timestamp, nonce, and the transaction. Any of these gets changed, your block hash value will change. Now, how the block is secured? We always say the blockchain, in the blockchain the block is secured, nobody can change, nobody can alter, it's very difficult to alter. Let us understand how it is secured. First, every transaction and a block in the blockchain is digitally signed by the creator using public encryption key. So, basically all your transaction is encrypted, your block is also encrypted, and we had seen that in the block hash value, because the block hash you cannot tamper with that. Now, any change or update in the old block resulting in the change in the hash block, as I said, whenever you make any change in the values except the block hash value of that block, any change, the block hash value change, and the moment the block hash value of the block change, the chain breaks. So, let us see, this is the green, you have block 172 which has a block slash value this, and this are same. Then this block 73 block has a block hash value which is again integrated with this, and this keep on going. Now, let us understand, I have a block 172, 173, 177 are depicted in different color. Why? Because somebody here is trying to change transaction T1 to T1. So, the moment I change this value, this block hash value changes. Now, the moment it has changed, the link from the 173 block and this, the value mentioned in the previous hash block of 173 is different from the block hash, and the moment we have a difference, this entire chain breaks. Now, how what to do? So, simply the moment is there, something goes bad. Now, the hacker or a corrupt miner who is trying to change the old blocks which has been where everything has been done has two options. First is either he or she generates the hash value for all the child blocks. So, I am saying let us consider what is the first value? He changed the block hash value for all these and keep updating the previous block. but it is very difficult, because understand the nonce value you have to keep on changing. So, every time you do not know which how many blocks is there, you have, in this case might be something 700 blocks. So, all the 700 blocks they have to keep on changing, and in the meantime other blocks are getting created and added to the 789, or transaction has been changed. So, you need to be very fast, at least 51% you have to be fast from the 51% of the other node, total nodes, then only you can change it. And even if you are able to change it, correct, then all the participants will automatically reject it, because they have the copy, of the blockchain where the address of the last block, which is 789, will differ from this one, correct, and it is difficult, and they reject that thing. Second option is somehow the miner or a blocker will change such a way that the block hash value of this 72 does not get changed. But this is not possible, because as per the blockchain all the hashing technique has to be collision resistant. When I say collision resistant, means in any case no two string values should be generating the same hash value. If that is the true, then no matter what you do, no matter how you play with the nonce, you will never able to get the same hash value with any of the value gets changed. So, this is how you make your blockchain secured. Now, let us talk about the versions of the blockchain. Interesting. So, we have version 1 long back, right? It is a simple state machine. You have a transaction recorded, somebody reads it, or we call it as a transaction. But the first version of the blockchain is basically the implementation of distributed ledger technology, which allows financial transactions to be based on the blockchain, and that is why the Bitcoin comes into the picture. So, blockchain 1 we call it as a Bitcoin, because Bitcoin was the first one who started implementing it, and that was meant, and they used it because of the distributed ledger technology. Blockchain 2. In this has been introduced as smart contracts. The smart contract is nothing but a contract between the two people, and this has to be, so whenever you make any change, that the transaction, the change history has been maintained. So, in blockchain 2 there is a capability where you can have a small program running, a small self executing programs that exist in the blockchain, and that has been used, and that is how the Ethereum come into the picture, and they adopted and implemented a smart contract, and we call it as the blockchain version 2. Now, in blockchain version 3 we call it as the dApps. Now, it is more than that, am I right? So, now till now we have a smart contracts and a financial contracts in the picture. Now, with this we come up with a decentralized application. Now, when we say decentralized application, you can have an application which has a front end, which makes a call to the back end and do the transactions. Now, even the front end can be deployed on a distributed architecture, blockchain architecture. There is something new is coming up, which is we called as a blockchain 4. So, when I say blockchain 4, that means now we are working, people are thinking that there will be a change where industry will start adopting it in a more and more new business models, and this is still in the work in progress. So, officially there is nothing like 4.0, this is more on work in stage, where we are saying blockchain 4 will be more for industries to use. So, if you see, if you summarize everything, am I right? There is a blockchain where we say, so two things are very important. First is security. Blockchain provides security through mechanism of cryptography, and all the participant has to verify it. We call it as a consensus process. Second, when somebody secures it, we need to generate a block hash. Now, to generate a block hash, people has to verify the block hash value and generate a unique block hash value which is as per the signature conditions. And to match the signature conditions, miners can keep on changing the value of nonce, and we called as, and the entire process is called mining process. And I just want to go one back. Security, once again we are saying the blockchain is secure. This is the reason, because whenever you make any spatial changes, it's a requirement that all the blocks has to be verified, and it's very easy to verify. So, for example, somebody has to verify the block is there any change in the block is, they only have to check the last block in the blockchain. If the signature remains, if the block hash of the signature is same, then there is no tampering with the blockchain. Thank you, and that's all for this lecture.